just for time's sake. Okay. Here we are. We had that fencing question. So grab yours, okay, and correct it because you're gonna also upload the corrected version of this, okay? But I have your original. So I think yesterday we got to the part where we had, I'm not quite sure where we ended up, to be honest, but let me just go over, right? We have narrow and wide. I don't think we even started. Okay, narrow and wide, right? Those are your variables, x and y. We have our implicit constraint. So if all those three components are there, you get 1 mark. I would be a bit more specific and actually go, let's say, number of narrow boards and number of wide boards, just so you know that it's discrete, right? Develop a system of inequalities which accounts for the requirements in this problem. Now, just like when there's minutes and hours, you have to have everything in minutes or everything in hours, right? It has to be 1 unit. It tells us that the narrow boards are 6 inches wide and the wide are 9 inches. And just to make sure, I give you a hint there as well. Okay, so you had that advantage there. So you either just go 6 divided by 12, right, to get 0.5 x, and 9 over 12, right, 9 over 12 inches, that's 0.75. So half an inch for every narrow board, 0.75 or 3/4 of an inch, 3/4 of a foot, I should say, for a wide board, and the combination of that has to be less than or equal to 150 feet. Yeah. Oh, yeah, yeah, yeah. That is just fine, as long as yeah. Okay, Anthony is telling me to the same thing. Yes. You know what? You will get the same answer. All right, you will get the same answer because right when you find your intercepts, it's still you're basically just multiplying or dividing everything by 12, right? Like it's the same thing. So you'll get the same answer. So let's just continue with this. If you don't, we'll talk about that. So yes, it is correct, right? Maybe I will say or 6x plus 9y is less than or equal to 150 times 12, right? So that would be 18, yeah, 1800. Yeah. So that is fine. Nothing wrong with it. Okay. As long as you have the same units, you're doing fine. Okay. And then it says that there must be no more than 90 narrow boards. So it's just talking to the narrow boards. So it's just x is less than or equal to 90. And this is different wording that you may have not seen so far, but no fewer. So you can have no less than 100 wide boards. So y has to be greater than or equal to 100. So very careful if you got that wrong. So every inequality is worth 1 mark. That's basically how I have it. So 1 mark per inequality. So give yourselves a mark out of 3 there. And then it gets tricky marking this later on a test or whatnot, because if you miss one of these, if you completely don't even have it, then the amount of work required in your graph is going to be less. So I also take off extra marks for that. Okay. Yeah. Uh, no, you don't have to. I always do that for your own benefit. In this case, it's also discrete, okay? Because it's number of boards. You can't have partial units because remember, We always go back to what is x and y, and it's discrete, okay? But I wouldn't take marks off if that's not written, okay? Now, here's your graph, okay? So, if you go that way and you go, yeah. So you should all have the exact same x and y intercepts as I have, regardless of what kind of inequality you used up there. If you use the 1800 one where you convert everything to inches, or if you use this one where you convert everything to feet. And so it's 300, 0, 0, 200. I rewrite this. You don't have to have the simplified version of this, but it's just 0.5 over 0.75, right? 0.25 goes in here twice, 0.25 goes in here 3 times. So that's how I simplified it. And it's solid, and you'll have to shade above because below the line is the true region. And then you have a solid, and it's a vertical line, so it's either left or right. Since the left is true, we shade right. You have a horizontal line here. It's also a solid line. And because it's greater than, meaning above is true, so we shade below. Okay. Then on my graph, I have number of wide boards here, number of narrow boards there. I use a scale of 50 given the numbers that appear. And then the first line I graph is my diagonal line, and I label it. Then I graph the vertical, which is the 90, right? X is less than or equal to 90. Then you do your horizontal, which is y is greater than or equal to 100. And so when you shade above on the diagonal, right, you shade to the right of the vertical and you shade below the horizontal, you're left with this polygon here. It's like a trapezoid, right? You're left with that. And so this is your solution region. It should be labeled. So if you see the mark allocation, you get 1 mark for all of this. I might give you more on a test because then it's easier to do. And then 1 mark for the graph. And here's the breakdown for the corner points. You get half for these 3 here because these 3 are fairly easy to get, right? But the 90, 140, that one is worth half a mark on its own. I put the keystrokes there. You don't need to do that. But I'm emphasizing this one because it's a little harder to get that one. You have to actually use your calculator for that. Okay. So 3 marks are associated with that. So for today, just for simplicity reason, right? If you forgot to come up with an inequality up there, and I only have 2 to graph here, I would immediately just go 2 out of 3 even if you did everything right and consistent. Okay. So so it's either, you know, perfect 3 out of 3, 2 out of 3 where you're pretty consistent except for you made a mistake above, 1 out of 3 if you did all the work but it's just not adding up, right? That's how I would do it today for simplicity purposes. And D, state the objective function which would determine the total cost of the fencing project. So this is how you would find the cost for the fencing project. And notice that the coefficients, which are the dollar amount per board, did not show up on in our inequalities at all. Okay, it was used here for the objective function. And so which combination would result in the least expensive project? Show your work. So basically, we type in all the corner points, and remember they have to be whole values, whole quantities. If it doesn't, for whatever reason, you get a decimal, you need to round them, okay? And so it's you just plug in the x and y into the objective function, and you get this option here, 0, 100 is the cheapest option. You identify that, and then you just make a little statement using only 100 whiteboards will be the cheapest option. And this will change, right? Like if the fence is longer, it will probably change. So don't think it's always going to be the same way. So this page, question 1, is worth 10 marks. So D is very independent, right? So basically you got it or you didn't. And then in E, if you have fewer corner points, right? In this case, if you used all the corner points you found in C in your graph, you still get the full 2 marks, unless you only have 2 corner points or whatever. If it's a significantly less amount of work, then I would take off marks there as well. Yeah. Okay. Well, yeah, well, you can't graph a vertical line, right? So what you need to do is, as I state here, you go second trace 1 and let x equal to 90. So you cannot graph a vertical, like if you have x and a number that's going to be a vertical, you can't graph that. Yeah, I wonder if it was a window issue or if you forgot to type in x. Yeah, did you change your window? Try try Zoom 6 and then go back to changing your window. Okay, but you were able to figure out the graph? Yeah. It would have to be exact because I know you can get the exact value with a calculator. It was close, yeah. Yeah. All right. So we're gonna go to the second page of this. And I'm probably gonna have to zoom out a bit here. Okay. I don't have a completely blank copy of this, so you're just gonna have to bear with me here. But regular shading has been applied. That's what it says at the top. Okay, it says regular, so meaning that whatever is shaded is actually the true region. And so if you want to talk about line A first, um, I try to find the y-intercept if it goes right through an intersection, and then you trace the line until that happens again, and it happens here. And then I make a triangle, right? And there's a vertical change of 2, right? And this is 5, a run of 5. And you notice that the line is decreasing from left to right. So that would be a negative slope. So for line A, I put down negative 2 over 5 for my slope. The y-intercept is 3. Okay, and I make a note that it is a solid line and above is true. So these are kind of like the 3 half marks that I'm looking for in your final inequality here. So it should be y is greater than because true is above the line, and it should be equal as well because it's solid. Then you have your slope and your y-intercept here. So if you get all of it right, of course it's 1.5. If you forget a negative, I would take off half. If you got this wrong, I would take off half if your inequality is facing the wrong way. And so that's how the breakdown is. For line B, I try to find my slope here as well. I get that it's going through -1, and then I trace the line until it hits an intersection, and it's right here. So there's a three unit. Sorry, that is wrong. 1.5, and this is 2, right? Because every 2 boxes is worth 1. So that's 1.5 over 2. Same here, this would be 1, but it ends up working out to 2.5, 2 over 5. So if you're wondering, if you're scratching your head, right, 2 boxes is worth 1, and this would be 1, 2.5. 1 over 2.5 is the same thing. If you multiply the top by 2 and the bottom by 2, you get 2 over 5. So that is still correct, and it's negative. Same thing here. It's just the way it worked out, but you have to be very careful with the scale here. This is 1.5 units and 2 units, right? So 1.5 over 2, if you multiply both of them by 2, that's 3 over 4. So it's still accurate to say that it's 3 over 4. And you have to see that you should be able to replicate this. Like if you go 4 boxes this way and 3 down, you should be landing right on the line, and that just continues, right? It's like a staircase. So this is a positive slope. Your y-intercept is -1. That is correct. It's dashed and below is true. So if it's dashed, it's just going to be, it's not going to have an equal, and below is true, then it should be less than facing that way. And this is your final inequality written down like that. Okay. If you just wrote the inequality and didn't show work, that's fine. Yeah. Yeah. I'm just breaking it down because sometimes students make mistakes and whatnot, and so that's kind of that's my rationale for it. So that one is worth 3 marks. Okay, question 2 was worth 3. And now I'm going to zoom in again. And here's one where you're asked to find if it's a solution to the system, if a certain point is in the solution region. And so you've got 2 inequalities. You have to be very careful with the x and y if it's not flipped or anything, because that can happen. And so basically you plug in these values into x and y, compute them, and for the first one you get a true answer. For the second one, you also get a true answer. So I would give you half for the work here, half for the work there, and then 1 mark for stating the right final answer, like yes it is, and what. So you didn't say if it is a solution or not? Take take off half. Take off half. 1.5 out of 2. Yeah. Yeah. Okay. So I want you to tally it up now and put a mark out of 15 at the top of this handout, and I will open a second slot. That is going to be the slot where you submit the marked version of your AC. Okay. So just give me 1 second. What's that? Okay. Well, try to do that whenever we go over. Okay. So let me just open that slot 1 second. All right, it's there now. You can go ahead and upload it. And once you've done that, we're going to continue with another AC, just like I mentioned yesterday. Okay, so go ahead and do that. It's out of 15. The first page is 10, and then the back side here is 15. Sorry, 5. So it's 15 total. 10 is the word problem. 5 is the back where you come up with inequalities and you check for the solution.